In this class, we are going to learn the first two exercises of trigonometry. Let us see how to measure the angle first. Let us take this as the initial side and this as the terminal side. We measure the angle in anti-clockwise direction. We call this as the vertex of the angle. Like imagine two hands of a clock. You are fixing this. This is fixed. You cannot move this. Okay, you are moving this hand in the anti-clockwise direction. So that's how we measure the angle. For example, this is 30 degrees, say. If you move further, it will become 60, 90. If it is vertical like this, the angle will be 90 degrees, etc. So if you keep rotating, this is, I told you, this is 90 degrees. And then you can bring it to this position. I told you this side is fixed. This initial ray is fixed. You cannot move this. This terminal ray, the terminal side, you can move. So this is 180 degrees. We measure it in the anti-clockwise direction. And if you move it further, you can bring it to this vertical position. This angle is 270 degrees. That is 180 plus 90, 270. And then you are rotating it and bringing it in this position. That is one complete revolution in anti-clockwise direction. So this is 360 degrees. 0 degrees is also same position. Whereas if you measure the angle in the clockwise direction, this is the initial ray, it is fixed. And then the terminal ray, if you move in the anti-clockwise direction, we take the angle as a negative angle. For example, we take it as minus theta. If you measure the angle in clockwise direction, we say that the angle is negative. So angle can take any value. It can be more than 360 also. It depends upon the number of revolutions it takes. This is the fixed ray. This is the initial side. If you go one complete revolution, you have covered 360 degrees. So you can go for the second revolution. So 720 degrees, etc. 750 degrees will be here, plus 30. This will give you 750 degrees. So angle can be any number. It can be more than 360. It can be negative. It depends upon how many revolutions it takes. How do we measure the angles? One unit is degree measure, which we have been using in lower classes. The other one is radian measure. Like to measure the length, we have two different units. We can use centimeters, meters. So like that, we have two different units to measure the angle: degree measure and radian measure. So whenever we learn two different units, we have to learn the relation between them also. Now radian measure is if you take a unit circle. Unit circle means with radius 1 unit, and take arc length also 1 unit. Radius is 1 unit. You are taking the arc length same equal to the radius 1 unit. Then the angle subtended at the center is 1 radian. Now the whole perimeter of the circle is 2 pi r. And the radius is r units. So if you divide by r, you will get the angle subtended at the center, which is 2 pi radians. So the angle, the complete revolution, the angle is 2 pi radians. That is 360 degrees. So 2 pi radians is equal to 360 degrees. So pi radians will be 180 degrees. This is the relation between degree measure and radian measure. In case if you have to convert degree measure into radian or radian measure into degree measure, you can do it using this relation. For example, to get the answer in radians, multiply the degrees by pi by 180. And to convert it into degree measure, multiply the angle by 180 by pi. This is the formula. It is given on page number 53, just above example 1. Mark these two formulae. And it is easy to remember. To get the answer in terms of radians, keep pi in the numerator. To get the answer in terms of degrees, keep 180 in the numerator. Pi by, here you have to multiply by pi by 180. Here you have to multiply by 180 by pi. Now arc length of a sector. This is a sector. Arc length of a sector, we denote it as L. If this angle is measured in degrees, say, then arc length of a sector is theta by 180 into pi r. This is the formula which we have learnt in lower classes. Whereas if the angle has been expressed in terms of radian measure, say, then the formula becomes L is equal to r theta. Here theta is in degrees and here theta is in radians. This is the formula to find the arc length of a sector if theta is expressed in terms of degrees or in terms of radians. This pi by 180 into theta makes it radians. Now we will see the relation between the standard angles. We will see the degree measure and the radian measure. 0 degrees is 0 radians. 30 degrees is pi by 60. Pi is 180 degrees. So 180 by 6 gives you 30 degrees. Then 45 degrees is pi by 4. 180 by 4 gives you 45 degrees. Then 60 degrees, that is 180 by 3. So pi by 3 radians. Pi by 3 radians is 60 degrees. Then 90 degrees is pi by 2. 180 degrees pi radians. 270 degrees is 3 pi by 2 radians. And 360 degrees is one complete revolution, which is 2 pi radians. So we can express the angle in terms of degree measure or radian measure. Now the value of pi. The approximate value of pi is 3.14, or we write it as 22 by 7. Even 22 by 7 is an approximate value of pi. It is not the exact value of pi. Pi is a non-terminating, non-repeating decimal. It keeps on going. So 22 by 7, 3.14 are all approximate values of pi. We will learn the smaller units of degrees. 1 degree is equal to 60 minutes. So minutes is represented by this dash. And 1 minute is equal to 60 seconds. These are the smaller units of degrees. 1 degree is equal to 60 minutes. And 1 minute is equal to 60 seconds. We'll do exercise 3.1, first question, second subdivision we will do. Find the radian measures corresponding to the following degree measure. It is minus 47 degrees 30 seconds. I can write this as 47 and a half. 30 minutes is half a degree. Let us change it into proper fraction. 47 into 2. 94 plus 1, 95. So it is minus 95 by 2 degrees. Now to change it in terms of radian measure, I have to multiply by pi by 180. So to change it into radian measure, keep pi in the numerator. So multiply by pi by 180. We will simplify. I'm cancelling 5. Which is minus 19 pi by 72. This is in radians. Third subdivision. We have to convert 240 degrees into radians. Multiply by pi by 180. The answer is 4 by 3 pi radians. If you don't write any unit here, it means radians. For degrees, we write this symbol. We write this. Second question. Find the degree measure corresponding to the following radian measure, and pi should be taken as 22 by 7. 11 by 16. This is given in radians. We have to convert it into degrees. To convert it into degrees, we multiply by 180 by pi. And let us substitute the value of pi. 11 by 16 into 180 divided by 22 by 7. 2 times. We can cancel further. (315) divided by 8. I am dividing 315 by 8. 3 8s are 24. 75. 72. 3 times 3. So 0.030. 24. 6. 56, 4, 40, 5 8s are. The answer is 39.375 degrees. We can convert the decimal point into smaller unit. This is 39 degrees. 0.375 should be multiplied by 60 because 1 degree is 60 minutes. Keep the decimal point here, so it is 22 minutes or 22.5 minutes. Now again 0.5 minutes can be converted to seconds. Multiply 0.5 by 60. So it is 30 seconds. We'll do one negative angle. Minus 4. Second subdivision. Minus 4 radians. So we have to change it into degree measure. To change it into degree measure, we multiply by 180 by pi. Substitute the value of pi, which is 22 by 7. It is 360 into 7. 2520 divided by 11. 2520 divided by 11. 22, 32. Again 2 times. 22, 10, 0, 99, 0. So it is 0, 9. 229.09. Again you will get 09. Now let us convert this into, this is degrees, this is in degrees. So 229 degrees, and to convert this, multiply by 60. 0909 we can take. 4 digits. 5.454 minutes. Minus 229 degrees, 5 minutes. Again we can convert 0.454 into seconds. Approximately 27 seconds. Third question. A wheel makes 360 revolutions in 1 minute. So in 1 minute it makes 360 revolutions. That is, in 60 seconds it makes 360 revolutions. Angle will be 360 into 2 pi. We have to give the answer in terms of radians. That's why I am writing 2 pi radians. For 1 revolution it covers 2 pi radians. So for 360 revolutions, 360 into 2 pi. This is made in 60 seconds. Now in 1 second we have to calculate. Therefore the angle covered in 1 second will be 360 into 2 pi divided by 60. 12 pi radians. In 1 second it covers 12 pi radians. Now fourth question. Find the degree measure of the angle subtended at the center of a circle of radius 100 centimeters. An arc length is given as 22 centimeters. Pi should be taken as 22 by 7. We have to find the angle in degree measure. So we will write the degree measure formula. Theta by 180 into pi r. This is the arc length formula when theta is expressed in degrees. The answer should be given in degrees. That's why I am using this formula. If we need the answer in terms of radians, we have to use r theta formula. This is equal to, this is 22, L is 22, theta we have to find, and pi is 22 by 7, r is 100. Therefore theta is 180 into 7 by 100. .6 divide by 10, so 12.6 degrees. We can change the decimal part, 0.62 minutes. So it is 36 minutes. Fifth question. In a circle of diameter 40 centimeters, diameter is given as 40 centimeters, radius will be half of it, 20 centimeters. The length of the chord is 20 centimeters. So chord is of length 20 centimeters, radius is also 20 centimeters. So it becomes an equilateral triangle. In the equilateral triangle, the angle subtended at the center will be 60 because it is an equilateral triangle. Find the length of the minor arc. So we have to find this arc length. This is the minor arc, and I have taken 60 degrees, so I will write the degree formula. Theta by 180 into pi r, 60 by 180 into, we will substitute pi as 22 by 7 into radius is 20. 440 divided by 21. 42, 20, it won't go, so 0. 11, 550, 2 times it goes. Okay, so approximately it is 20.95 unit is centimeters. Question 6. If in two circles arcs of the same length subtend angles 60 degrees and 75 degrees at the center, find the ratio of their radii. So we are having two circles. Arc length are same. So we will take two arcs in these two circles. These two arc lengths are same, but they subtend the angle 60 degrees in the first circle and angle 75 in the second circle. Degree measures are given. Find the ratio of their radii. We will take the radius of the first circle as R1, radius of the second circle as R2. Let the radii be R1 and R2. Arc lengths are same. We are going to use the formula. The angles are given in degree measure, so we are using degree measure formula theta by 180 into pi r. So the first arc length is 60 by 180 into pi into r1. Arc length of the second circle 75 by 180 into pi r2. (180) could be cancelled. So R1 divided by R2 is 75 over 60. We can simplify, cancelling 5. Again we can cancel 3, 5 and 4. So R1 is to R2 is equal to 5 is to 4. Question 7. Find the angle in radian through which the pendulum swings if its length is 75 centimeters and tip describes an arc length 10 centimeters. The arc length is 10 centimeters, it is given. Radius is 75 centimeters. L is equal to 10 centimeters. We have to give the answer in radian measure. So we will use arc length formula, which is expressed in radian measure. So here theta has to be expressed in radian. 10 is equal to 75 into theta. Theta will be 10 divided by 75, which is 2 by 15 radians. Similarly, second subdivision, theta will be L by R. Here L is given as 15, R is 75. The answer is 1 by 5 radians. Third subdivision, same formula. Theta has to be expressed in radians. 21 by 75, which is 7 by 25 radians. Now trigonometric functions. We have learned sine theta as in a right triangle. If this angle is theta, sine theta is opposite side by hypotenuse. Cos theta is adjacent side by hypotenuse. And tan theta is opposite side by adjacent side. And cosecant theta is reciprocal of sine, which will be hypotenuse divided by the opposite side. And secant is reciprocal of cos. So secant theta is hypotenuse divided by the adjacent side. And cot theta is reciprocal of tan theta, which is adjacent side by the opposite side. And then we learned the identities. First identity is sine square theta plus cos square theta is equal to 1. And this identity can be written in these two ways also. Sine square theta is equal to 1 minus cos square theta. And cos square theta is equal to 1 minus sine square theta. And then the second identity, we can divide by sine square. Divide this by sine square. Sine square by sine square is 1. And cos square by sine square is cot square. And 1 by sine square will become cosecant square. This is another identity. Same way, this identity also can be written in two different ways. Cot square theta is cosecant square theta minus 1. Cosecant square theta minus cot square theta is equal to 1. Third identity, divide the first identity by cos square. So sine square by cos square is tan square theta. Cos square by cos square is 1. And 1 by cos square is secant square. This is the third identity. And this also can be written in two other ways. This is tan square theta is secant square theta minus 1. And secant square theta minus tan square theta is 1. Now see page number 57. You have to memorize the values for the known angles 30, 45, 60, 90. Memorize those values. Then sign of trigonometric functions. X-axis, Y-axis. We call this as the first quadrant. This is the second quadrant. And third. And this is the fourth quadrant. We go in anti-clockwise direction. In the first quadrant, both X and Y are positive. And in the second quadrant, X is negative, Y is positive. In the third quadrant, X is negative, Y is also negative. And in the fourth quadrant, X is positive, Y is negative. Now let me draw a unit circle. Unit circle means circle with radius 1 unit. This is the origin, x-axis. Let us consider a point P whose coordinates are x and y. I am taking this point P in the first quadrant. So both are going to be positive. I am drawing a right triangle. This is the radius of the circle, which is 1 unit because I have drawn unit circle. I am drawing a perpendicular on the x-axis. This distance is x and this distance is y, and the hypotenuse is 1 in this right triangle. Let this angle be theta. Sin theta from that right triangle is opposite side divided by the hypotenuse. Hypotenuse is 1. Y by 1 is y. Cos theta is adjacent side by the hypotenuse, which is x. And tan theta is sine by cos, or opposite side by adjacent side. Now cosecant theta. Cosecant theta is reciprocal of sine, we know. And secant theta is reciprocal of cos. Cot theta is reciprocal of tan. Now if you see, all these 6 trigonometric ratios are positive because both x and y values are positive. So all trigonometric ratios are positive. In the first quadrant, all trigonometric ratios are positive. Now let us take a point P in the second quadrant. I am drawing a unit circle. I am taking a point P in the second quadrant. We know that in the second quadrant, x is negative, y is positive. Let us draw a right triangle. I am drawing a perpendicular line. Let me take this angle as theta, the reference angle we call that as. I am using this right triangle. Actually the angle covered is this. But to get the right triangle, we have completed the triangle here. Minus x and y. So from this right triangle, sin theta is opposite side by the hypotenuse. Hypotenuse is 1 unit because it is a unit circle. Cos theta is adjacent by the hypotenuse. Hypotenuse is again 1. Tan theta is opposite side by the adjacent side. Cosecant theta is reciprocal of sine, which is 1 by y. Secant is reciprocal of cos, which is minus 1 by x. And cot theta is minus x by y. Now see these 6 trigonometric ratios. Sin theta and its reciprocal cosecant theta are positive. All other trigonometric ratios are negative. So we can conclude that in the second quadrant, if the angle is a second quadrant angle, what do you mean by second quadrant angle? It should be, the angle should be more than 90 and less than 180, between 90 and 180 degrees. Okay, then we form this right triangle and we find the trigonometric ratios of that angle. So sine and cosecant are positive, other trigonometric ratios are negative. So I will denote it as S here. Sine. S stands for sine and its reciprocal cosecant. In the first quadrant, all trigonometric ratios are positive. In the second quadrant, sine and cosecant are positive. Now let us see what happens in the third quadrant. Take a unit circle whose radius is 1 unit. I am taking the angle in the third quadrant. This angle is the third quadrant. Now I have to complete a right triangle to find the trigonometric ratios. I am drawing a perpendicular to the x-axis. I am going to use this right triangle. P point is in the third quadrant. In the third quadrant, x is negative, y is also negative. This is minus x and this is minus y. We will take this as theta. This is the reference angle. Now sine theta is equal to opposite side by, that is sine of this angle and this angle are going to be the same. So sine theta is opposite side by the hypotenuse. Hypotenuse is 1. Cos theta is adjacent side by 1, minus x by 1. Tan theta is opposite by adjacent. Cosecant theta, reciprocal of sine. Secant theta, reciprocal of cos. And cot theta, reciprocal of tan. In this third quadrant, tan and cot are positive. All other trigonometric ratios are negative. Let me denote in the third quadrant T. That means tan and cot are positive. Other trigonometric ratios are negative if it is a third quadrant angle. In the first quadrant, all are positive. In the second quadrant, sine and cosecant are positive. Other trigonometric ratios are negative. In the third quadrant, tan and cot are positive. Other trigonometric ratios are negative. Now let us take a fourth quadrant angle we will consider. I am drawing a unit circle. Take the point P in the fourth quadrant. In the fourth quadrant, x is positive, y is negative. Let me complete a right triangle. I am drawing a perpendicular on the x-axis. I am going to consider this right triangle. Here this is minus y and this is x. We will take this as the reference angle theta. Now sine theta is equal to, that is this angle. Sine theta is opposite side by hypotenuse. Hypotenuse is 1. Cos theta is adjacent side by hypotenuse. And tan theta is minus y by x. Cosecant theta is reciprocal of sine. Secant theta reciprocal of cos. Cot theta is reciprocal of tan. Now in this quadrant, cos and sec are positive. Other trigonometric ratios are negative. Therefore, in the fourth quadrant, I can say that cos and secant are positive, other trigonometric ratios are negative. First quadrant, all are positive. Second quadrant, sine and cosec are positive. Third quadrant, tan and cot are positive. And in the fourth quadrant, cos and secant are positive. Other trigonometric ratios are negative. To remember, we say all silver tea cups, or STC. STC is easy to remember. ASTC. All students take calculus. We can remember easily. We know the formula for sine theta. Sine theta is opposite side by the hypotenuse. We know that hypotenuse is the longest side in the right triangle. So, denominator is always bigger than the numerator. I can say that sine theta is always less than or equal to 1. Because the ratio denominator is a bigger thing. That's why it is less than or equal to 1 and greater than or equal to minus 1. According to the quadrant, sign may be positive or negative. That's why we say that sine theta always lies between minus 1 and plus 1. Similarly, cos theta formula is adjacent side by hypotenuse. Here also the denominator is a bigger quantity, therefore it is less than or equal to 1. According to the quadrant, it may be positive or negative. Remember that sine and cos takes values only between minus 1 and plus 1. They never take the values more than 1 or lesser than minus 1, because numerator cannot be bigger than the denominator. Whereas tan theta and cot theta can take any value. Tan theta is opposite side by the adjacent side. We don't know which one is bigger, which one is smaller. Numerator can be bigger than the denominator, or they may be equal, or denominator may be bigger. Therefore, tan theta can take any real value. Tan and cot, they take any real value. Whereas cosecant theta is hypotenuse divided by the opposite side. So I can say for sure that the numerator is always a bigger quantity. Therefore, cosecant theta takes values bigger than 1 and lesser than -1. The opposite of sine and cos. Secant also. Bigger than 1 and lesser than -1 it takes. Now, given a trigonometric ratio, we can find, using that we can find the other 5 trigonometric ratios using triangle method. Exercise 3.2. First question. Cos x is equal to -half. It says that x lies in the third quadrant. Don't forget the ASTC rule. ASTC, all silver tea cups. Now use a triangle method. Cos is adjacent side by hypotenuse, and we can find the opposite side. 4 minus 1. 2 square minus 1 square. 4 minus 1 is √3. In the figure you can write the positive numbers, but when you write the ratio, see the quadrant, accordingly you have to write the sign. I have to find the other 5 trigonometric ratios. Sin x, sin is opposite by hypotenuse and in the third quadrant. In the third quadrant, see the third quadrant, only tan and cot are positive. All other trigonometric ratios are negative. So sin is negative, minus √3 by 2 you have to write. Now tan is sin by cos. So √3 by 2 you can write. √3 by 2 by half, 2 will get cancelled, √3. Now cosecant x. Cosecant x is reciprocal of sine. So -2 by √3. Secant x is reciprocal of cos, so -2. In the third quadrant, cosecant, secant are also negative. Cot is positive. Reciprocal of tan, which is 1 by √3. So easily we can write, but don't forget to keep the quadrant in mind. Accordingly, you have to write the signs. We will do the third question. Cot x is given 3 by 4 and x lies in the third quadrant. In the third quadrant, we know that tan and cot are positive, other trigonometric ratios are negative. We will use triangle method. Cot is adjacent side by opposite side. So hypotenuse will be 16 plus 9, 25, √25 is 5. We will find sin x. Sin is opposite side by hypotenuse. And in the third quadrant, sin is negative. Don't forget the quadrant. Accordingly, you have to put the sign. Cos x is adjacent side by the hypotenuse, but cos is negative, yes, but cos is negative in the third quadrant. Tan x, reciprocal of cot, so 4 by 3. Cosecant x is reciprocal of sine, negative. Secant, reciprocal of cos, which is also negative. And cot is already given in the question. Fifth question. Tan x is equal to -5 by 12. and x lies in the second quadrant. In the second quadrant, sine and cosecant are positive, all other trigonometric ratios are negative. Let us use the triangle method. Tan is opposite by adjacent, so hypotenuse will be root 13, that is 25 plus 144, 169. Root of 169 is 13. Let us find sin x. Opposite side by the hypotenuse. Sine is positive in the second quadrant. Cosecant is also positive. Reciprocal of sine. Then cos x will be negative in the second quadrant. Cos is adjacent by hypotenuse. Reciprocal of cos is secant, which is minus 13 by 12. Tan is already given in the question. Cot x is reciprocal of tan, which is minus 12 by 5. You can try the other two questions by yourself. Now we will do the next question. Sixth question. Find the value of trigonometric functions in exercises 6 to 10. Sine 765 degrees. For example, see, 30 degrees is this position. 360 plus 30 is 390 degrees. 390 degrees is one complete revolution and 30. It comes to the same position. 30 degrees and 390 degrees will take the same position. So sine of 30, sine of 390 are same. Similarly, cos and cos values, cos 30 and cos 390 will be same because they take up the same position. Okay, we call them as periodic functions. So after one revolution, it takes the same value. Now I can write sine 765 as 720 degrees plus 45 degrees. So 720 degrees is two complete revolutions. It will take up the same position as 45 degrees. Therefore, sine 45 value and sine 765 degrees values are same. And sine 45 value we know 1 by root 2. Therefore, the answer is 1 by root 2. Question 7. Minus 1410. If you add any number of complete revolutions to an angle, it will go to the same position, so the value does not change. So what I am going to do is, I will add 360 into 4. 4 complete revolutions I am going to add. So I told you any number of complete revolutions, positive or negative, you can add to the angle because it comes to the same position. The value of the trigonometric function does not change. So I am adding 4 complete revolutions and the angle is negative here. So it makes it positive 30 degrees it becomes. So cosec plus 30 degrees and cosec minus 1410 degrees are taking up the same position. See, 30 degrees is here. And minus 1410 is one revolution, second, third and fourth, it comes here. Okay, which is minus 1410 degrees. So they take the same position. Therefore, the values of cosecant 30 degrees and cosecant minus 1410 degrees are same. Sin 30 is half, cosecant 30 is 2. 8th question. Tan 19 pi by 3. 2 pi is one complete revolution in radian measure. So I can write this as 6 pi plus pi by 3. Take LCM and check. 6 3s are 18 pi plus 1 pi gives you 19 pi. And 6 pi is 3 complete revolutions. So it will take up the same position as pi by 3 angle. Therefore, tan pi by 3 and tan 19 pi by 3 values are same. Tan pi by 3 is tan 60, which is root 3. Therefore, tan 19 pi by 3 also takes the same value, which is root 3. Ninth question. Sine of minus 11 pi by 3. Minus 11 pi by 3. I can add 4 pi to it. 4 pi is 2 complete revolutions. 4 pi is 2 complete revolutions. I am adding any number of complete revolutions can be added to an angle. The value does not change. Let us take LCM. It becomes pi by 3. So sine pi by 3 and sine of minus 11 pi by 3 values are going to be the same, which is root 3 by 2. Question 10. Cot of minus 15 pi by 4. I can add any number of complete revolutions to it. I am adding 4 pi, 2 complete revolutions I am adding. Take LCM. It gives pi by 4 and cot pi by 4 is 1. That's all. Bye bye.